My name is Jerker Sjögren. I am an independent consultant. I was early in the Ministry of Transport in Sweden, and it's a pleasure for me as chairman for the working group, the OECD ITF working group on high-capacity transport, to welcome you all to this special session, the ITF in Focus session. We took an initiative in 2012-2013, Sweden, together with Australia. In Sweden, we have at that time set up a comprehensive program for research and innovation in this field, talking not only about heavy and longer vehicles, but to look on these vehicles as part of the entire transport system, with all the pros and cons for these solutions. And at the same time, we had learned our friends in Australia, down under, that they were very experienced, so it made a very good combination, Sweden and Australia, in this field. And Chris Konadisotis, that we will listen to later, and I will started to talk about the idea of a new working group for these issues. So finally, it was done, and now we are more or less mid-term in the work, so we take the opportunity to talk to you, all of you, about what we have done so far and what we are aiming for until the end of June next year, when we are going to come out with a hopefully very good report. Not only nice report, but also useful. The program for today is that we will have 4 speakers, and I will introduce as speaker number 1, Alan McKinnon. He is professor at the Kühne Logistics University, the only logistics university in the world, you ought to say. And it's a pleasure for us to listen to you, to put all these things in the context of decarbonization, which is one of the most burning issues for the moment. Welcome.
Thank you, Jerker, for that introduction. Just about the university, it is the only one in the world that we know of that specializes in logistics. It's based in Hamburg. We're only 7 years old, but keep an eye on it. We've got big plans for developing. If I can get my presentation, please. Okay. That's fine. Okay, as Jerker said, I mean, if one looks at all the arguments in favour of moving to high-capacity transport, one of the most forceful is that it is a way of decarbonising freight transport. And so what I'm going to try and do in the next 15 minutes is present you with some data and some arguments to support that point. Might be worthwhile, if I can move it on, to say a few things about carbon emissions from freight transport. If one looks at the latest ITF Transport Outlook report and also looks at data on total global CO2 emissions, you can find that in 2015, freight transport worldwide, all transport modes, accounted for about 8.8% of greenhouse gas emissions. The ITF report also projected forward to 2050, suggesting that on a business as usual basis, by 2050, freight might account for about 5.7 billion tonnes of CO2. If one looks at the latest IPCC assessment report from 2014, it suggests if we want to stay within the 2-degree temperature rise by 2100, then all man-made emissions of CO2 will have to be limited to 20 billion. In other words, if nothing is done about freight alone by 2050 could be 29% of our allowable emissions. So clearly we will be requiring deep reductions in the carbon intensity of freight. We don't as yet have a global target for cutting emissions from freight transport. There is an initiative underway, the Science Based Target Initiative, to which about 200 companies have so far subscribed, which is currently consulting on what would be a realistic target for cutting carbon emissions from freight. Here in Europe, however, the 2011 White Paper on Transport set targets for decarbonising transport. Now, if the freight sector is to meet those targets at an EU level, then that will require an 80% reduction in the carbon intensity of freight transport between 1990 and 2050. And that is going to be a very tough challenge to meet. So that's the background, in a sense, to what we're talking about in this session. Those of you who work in this area will know that there are various analytical frameworks that you can apply to try to determine how you decarbonise freight transport. The one that we tend to use is the one on the right there, which we call the Green Logistics Framework, which suggests there are 5 things you can do to decarbonise freight transport. You can reduce transport intensity, just reducing demand for freight transport. You can shift transport mode, you can improve vehicle load factors, you can improve energy efficiency, or you can switch to lower carbon transport modes. Now, what we're talking about this afternoon, high capacity transport, really relates to 2 of those, improving vehicle load factors and also improving overall energy efficiency. The latest figures I've seen for Europe suggest that only about 4% of road ton kilometres move by high capacity transport in longer and heavier vehicles. So there's a big potential to increase that figure. Some years ago, I developed an analytical framework that you can use for assessing the costs and benefits of increasing the maximum size and weight of trucks. It's a rather complicated framework. Thankfully, this afternoon, I'm just focusing on one box in that framework in the top left-hand corner, just looking at CO2 emissions. So I'm not saying anything about other pollutants, about safety, about risk, and so forth. So what could the contribution of high-capacity transport then be to the decarbonisation of road freight? There are various companies make claims. A trucking company in the UK that's developed a longer, heavier vehicle claimed you can cut your CO2 emissions by between 8 and 16%. There have been larger scale trials in the Netherlands and in Germany, and they have been very positive. I've extracted some quotations from the relevant reports. In the case of the Netherlands, for example, they said that for road transport, this is an important innovation in the effort to reduce CO2 emissions. And then more recently, as I'm sure many of you will be aware, the German government has approved gigaliners, longer and heavier vehicles, for general operation in Germany. And the study done by BST, again, partly justified that decision on the basis of the carbon reductions that can be achieved. The International Road Transport Union, in its report recently on the commercial vehicle of the future, makes some projections about the extent to which high-capacity transport can cut carbon emissions in the European road freight sector. So they reckon that by 2030, HCT could achieve about a 3.5% reduction in CO2 emissions, and potentially by 2050, a 7.5% reduction in CO2 emissions. Not huge, but nevertheless a significant contribution. And then in the UK, research centre that I was involved in, and David Sabon, the director of the centre, is here, did a project for the Committee on Climate Change in the UK, looking at all the ways of decarbonising road freight transport in Britain up to 2035. And they reckoned that by the early 2030s, up to about a quarter of the carbon savings would come from the use of longer and heavier vehicles. So a lot of evidence to suggest that this is a very positive way of decarbonising freight transport. Now, if we simply focus on the vehicles, things are relatively simple. I'm going to be talking mainly about the 25-metre longer, heavier vehicle with a carrying capacity of 50 or up to 60 tonnes. That would give you a 3-for-2 substitution. We can replace 3 trucks with 2. And that translates into greater load consolidation and improved energy efficiency per tonne kilometre. If one reviews the literature in this area, again, there have been studies done in various countries, you can see that that would save between 10 and 20% of fuel consumed and also of CO2. It partly varies because different countries and different studies have used different maximum weight figures for these vehicles. So it's very hard to compare much of the data on the public domain because different methodologies were used, the geographical areas differ, some of the assumptions made about price elasticity. So it's hard to make an overall conclusion. But the other challenge is moving from a vehicle-based perspective to a system-wide perspective. If you allow this at a country level, what would be the macro-level impact? Why is that difficult? Partly because of the diversity of longer and heavier vehicles. Very heterogeneous set of possible vehicle configurations. The other problem is that the freight varies a lot. One of the key determinants of the carbon benefits you get is the density of the freight that's being moved and how that relates to the size and the weight restrictions as well. Again, interesting work has been done in this area, partly in connection with the last OECD study on this subject, which was published back in 2009, where they looked at 39 different configurations of truck. Some of them the standard workhorse vehicle at the time, others high capacity or even very high capacity vehicles. John Woodruff, who will be speaking in a few moments, was one of the contributors to that study. They also came up with a nice metric. It was a composite measure of freight density that took account of both the cube as well as the weight. So this graph shows the energy efficiency of these different vehicles, and the capacity of the vehicle increases as you move from left to right, and it shows quite clearly that the higher capacity vehicles deliver greater energy efficiency and reduce carbon emissions per ton kilometre. And the other problem you have in going from a vehicle perspective to a system perspective is the geography, because it's generally accepted that these longer and heavier vehicles will move on a more restricted road network. And there's a possibility therefore that the journeys that these vehicles will make will be more circuitous. So if there are additional vehicle kilometres to be run, then that will partly erode some of the carbon benefits. So therefore we have to look at the issue of network access, which I think Chris will be addressing in his presentation later. Then pulling back further, in going to the system, we have to look at the freight market and the level of adoption of these vehicles, and also their impact on freight modal split. Because, as I'm sure you're all well aware, these vehicles will make the movement of freight by road cheaper. It will improve its competitiveness, and therefore can divert freight from other lower carbon transport modes like rail or water. I was involved in a study in the UK that looked into longer, heavier vehicles back in 2007, 2008. And we did a lot of modelling at that stage of the impact of longer and heavier vehicles on the freight modal split in the UK, mainly between road and rail. And the results of that analysis depend very much on the elasticity values, the cross-modal price elasticity values factored into the model. But there's no denying that there will be some erosion of freight traffic from alternative modes. Whether it will be as bad as the railway sector would like us to think is another matter. Clearly there's been a lot of lobbying against high-capacity transport by people on the railway side. I'm sympathetic to many of those arguments, but my feeling is that people have been exaggerating the cross-modal elasticities, and that this will not be as damaging to rail as people project. It's also been argued if we make road freight cheaper, companies will make more use of it. They will reconfigure their supply chains, and they will lengthen the distance the freight moves, and that will generate more ton kilometres. Again, the available evidence on that suggests that is unlikely to happen. But critical to all of this are the elasticity values that you factor into the models. In connection with the project that Jerker mentioned, we ran a workshop in Cambridge back in December where we focused specifically on these elasticity values. they vary a lot by freight market, by country, by sector, and so it's very difficult really to generalize. But I do flag this up as one of the controversial issues in the decarbonisation of freight transport, this conflict between, on the one hand, trying to improve the efficiency and the carbon efficiency of road freight, and on the other hand, trying to shift more freight onto alternative modes. These two things are in conflict, and it would be nice if we could find a way of reconciling that. And then pulling back further, one has to look at how supply chains, logistics systems will adapt to the use of high-capacity transport, because that will influence the uptake of these vehicles, the extent to which loads migrate from the existing vehicles to these longer and heavier ones. It will also relate to the capacity utilization, because a lot of the models here assume that the trucks will be full on every kilometre they run, and clearly that is not the case. So again, we've got to have realistic assumptions about how well that extra capacity will actually be used. Anyway, if you factor all that together, there are a few studies I came across which have tried to look at the effect of high-capacity transport on freight transport CO2 emissions as a whole. Again, the results vary. For the reasons I've mentioned earlier, because the studies were done in different countries using different methodologies. Overall, it suggests you can get between a 2 and a 6% reduction in your CO2 emissions by moving to high-capacity transport. So just to conclude with a few general points, if you simply focus on the vehicles and the vehicle substitutions, you can be getting a 10 to 20% reduction in CO2 emissions per tonne kilometre. It's hard to go from the vehicle to the system level for the reasons I've mentioned, because you've got to make assumptions about adoption rates, modal shift, vehicle load factors. But on the basis of the available data, it would suggest you can get about a 2 to 6% reduction in CO2 emissions from freight transport as a whole. Just one other point I will make before I end. If you review all the studies that have been done, you can divide them into two categories. The ones that are based on theoretical modelling and simulation, and the ones which are based on real-world experience. And the latter category suggests the CO2 emissions are greater. And they're therefore, to my mind, are the more credible of the studies that have been done so far. So just to conclude overall, it seems to me that high-capacity transport can make a significant contribution to the decarbonisation of road transport and also transport in general. Thank you very much.
Thank you very much, Alan. And I didn't say it before. In the end, we will put a panel here with the speakers and also a few other experts to comment and to summarize what has been said earlier during the session. Now it's an honor to present Chris Koniditsotis from Melbourne, who has taken his time to fly again over to Europe and make us happy with a presentation here today. Chris is CEO for Transport Certification Australia, and I think that you will say a few words about that organization also. Not only what you have done, but also what you are.
Okay.
Welcome.
Thank you.
The floor is yours.
Thank you, and it's again an honour for me to be here and present to you. I have 15 minutes, which is now 14 minutes and 50 seconds. So I have 24 slides, which according to the rules is in excess of 15 minutes. So I'm going to have to be very to the point and brief. And to address your question, Transport Certification Australia is a government-owned organisation in Australia. Its purpose is effectively to administer the programs which use technology and technical providers to ensure that not only our heavy vehicle regulators but other regulators who we deal business with can achieve the public policy outcomes they want. Our job is to manage the market of the technology providers. Today I'm here to talk about the Intelligent Access Program and the way it's been used to effectively provide enhanced access to the road network for high-capacity transports. I'm going to talk a little bit about the framework that we have, and then, in particular, the Intelligent Access Program, its status, the lessons learnt, and the program going forward. When someone says, just put a GPS system in a truck, what do they mean? Do they mean going and buying a Garmin or TomTom navigational device? Do they mean grabbing your mobile phone into GPS mode? Australia realised that the word putting a GPS system into a truck or a taxi or a car meant a system that we had trust and confidence in when we wanted to use the data, not just for research purposes, but more importantly, when I have to stand in a courtroom and justify to a judge who knows nothing about GPS, and I have 15 seconds to say to them, you can trust the data. The National Telematics Framework, which is now an ISO standard, gives us that trust. It's a certification process that allows us the confidence. And ISO 15638, as you'll see, we lobbied to get 9008, 9009, but ISO gave us 15638. So I can never remember it, but Framework for Collaborative Telematics Applications for Regulated Commercial Vehicles is the standard that we use to ensure that the data that is collected is assured. And I want to stress that. It also means it's a standard that is technology agnostic, it is performance-based, it removes the hard wiring of the policy intent from the solution. If you look at technology disruption that occurs, it's because someone didn't think and they hardwired the problem into the solution. If you look at Uber, they came along and said, I don't want to charge based on what the rotopulsar says of a taxi meter. I want to have a fixed price. And the regulator said, you can't do that. The taxi meter must be wired into the vehicle to give you distance measurement. And they said, we don't want to do that. But our entire regulatory environment had that hard wiring. Very important that that separation occurs. Multiple providers. Now, why is this important? I always like presenting this slide here in Europe because it's a slide about my heritage as a European of Greek extraction. This is a picture of a truck that I took at the border between Switzerland and Germany. It had come through for checking, and I jumped on board and I realised it was a European truck and not an Australian truck. Not because the steering wheel was on the other side. I realised that because every policy intent had its own technical solution. What you'll see from there, working from the left onwards, is a navigational system. Next to it is the Austrian E-tag. Next to that is the Swiss tolling device. Next to it is the German tolling device. You can't see it, but above it is the digital tachograph. All of these systems collect the same information. They collect it in exactly the same way. But that transport operator must have each one of those systems in because no one trusts the other. In Australia, we decided we're going to use the framework and have one box, many uses, which means it's cheaper for us to use. And at the same time, you can have the necessary levels of trust that are necessary for different regulators and users. So I like this picture because it highlights the world that you could have had, but unfortunately in Europe you don't have, so unfortunate for you. The Intelligent Access Program is effectively a program that provides the industry a new way of doing business. In other words, we will let you have the big truck, the gigaliner. We will let you have greater mass. We will let you go down roads that otherwise you wouldn't be allowed, but in return, you as the operator must demonstrate compliance with route compliance, speed compliance, temporal compliance, and mass compliance. Simple as that. So in other words, rather than saying you can't do something, in Australia we say, We will allow you to do it as long as it's the right truck on the right road at the right time, within the permitted speed, and as of a few months ago, with the right mass. A completely reversed business model. I will give you 2 examples of this in use. This is the first one. This is an example, I'll be very quick, of microeconomic reform. Because ultimately, why do we have these bigger trucks? Because they are dealing with an economic problem. This is a site of a mining location in Western Australia. 3 mines. The drop in the iron ore commodity price effectively made these mines uneconomic. In other words, the cost was greater than the floating price of iron ore. So the government of Western Australia was faced with, well, let's just close them down. But the economic impact of that, the social impact of that was significant. They also determined that the land cost of the mine, in the worst case 400 kilometres to the port, represented the most significant cost. As soon as it got onto the ship, it was irrelevant. But getting it to the ship was the most expensive cost. In WA, they have very large trucks, and the largest vehicle is a 53-metre long road train. Even that was uneconomic. In other words, it wasn't big enough to make these mines economic. So the Western Australian government decided we will use IAP and effectively have the largest vehicle on the public road network. A performance-based standards vehicle, super quad, 60 metres in length. 199 tonnes gross vehicle mass, 144 of those are payload. It operates 24/7 on the public road network. It is monitored and it has a maximum speed of 90 kilometres an hour. And I can assure you, as I've been sitting here, every 3 seconds in Melbourne, the data is being received to confirm that. And it's used. And prosecutions occur. It's also monitored for headway compliance. In other words, 2 vehicles can't be closer than 200 metres, because if they are, no one can overtake. And that's monitored as well. The bottom line is, this use of this vehicle has made it an economic solution for the country to be able to compete regionally and internationally. We have one of the few countries that have been able to keep these mines operating at a price point which has been able to withstand a 70% reduction in the price of iron ore. And the solution has been not simply giving them more access, but actually managing the access through compliance systems, and that's what's important. The status of IAP, we have 5 IAP service providers. Navman Wireless is a service provider. It's an international company. C-Track, these are well-known telematics providers. They're all certified. We have over 32,000 prime movers out of the 80,000 in Australia, which have a type-approved capability. 1,200 operators are operating as we speak. 7,500 electronic access conditions across 4,000 vehicles as we speak now. And as I mentioned, every 3 seconds, information is being collected. Every month we have 40 new vehicles entering the program. We have about a 10.5% to 13% increase annually. My pension fund doesn't get that much. So I've invested in the wrong area. The silent majority of operators in Australia don't want to talk about IAP because they can't afford to. Because if they come to a presentation like this and present, their competitors hear it and then they have competitive pressure. So they will not talk about the benefits because they don't want the competition to know. In compliance and enforcement, the overwhelming use of the information is by an operator to manage their operations and make them more efficient. However, regulators do use it for educational programs. They do apply penalties and sanctions, and as necessary, we use the data in a courtroom to take legal action. And that happens because that's the deal. Remember the partnership I said. We're giving you access, but in return, you're giving us compliance. And if someone doesn't perform the deal, then we end up taking action. Some of the issues, operators say it's too expensive, the technology is too expensive, and so forth. At the end of the day, it's voluntary. You can stay with the smaller vehicle. If the price point is not sufficient, then don't move. There's complaints that the IAP is not applied consistently across the country, and that's very true because we have a federated environment. In Australia, each state can make its own laws, and sometimes they are inconsistent. When the Australian Constitution was drafted in 1901, it was decided that lighthouses were more important, so that was done nationally. Land transport was seen as, well, you can only ride a horse for 20 kilometres, let the states do it. And now, so we do have inconsistencies in their use. IAP probably hasn't solved the first and last mile, because the simple fact is that these are political decisions as much as technical ones. So it solved some of them, but not all of them. Other lessons is that we're still 17 years on. We are still trying to tell local government that road-friendly suspensions are road-friendly. Local government tells us they're road-friendly when they're new, but there's no management process to make sure how they're performing when they're old. And sometimes they're worse. So that is still an issue for us. Have the full benefits been realised? Probably not as much as I would have hoped, but what are the reasons for it? There are many reasons for providing access to a road network, and some of them have nothing to do with what I'm talking about. They are as political as anything else. We have institutional issues. Sometimes we're just too caught up with today's business rather than to look at reforms, and we come to conferences like this to learn, but sometimes we don't take it back to our hometown. We lack champions. These reforms require someone to stay the course for 5, 6, 10 years. At a time and place when people want to move every 3 years, you lack the champions. We're only now realising the data-rich environment that we have, and only realising and to be able to use it in a better way. Moving forward, we are making enhancements to the program as we speak. The first enhancement is that we know that we can have now real-time reporting. And why is that important? Because a lot of road managers tell us that we will now allow access to certain vulnerable bridges as long as we know within a certain period, i.e. near to real time, if a compliance is ready to occur so we can take action. Technically we can do this, so we're going to implement it. The other aspect is no reporting. In other words, the data is collected and it's audited, maybe once every 6 months or once every year or 2 years. In other words, it's risk-based, and I think that will increase the take-up because it will align it to the different risks that we have. The other thing that's very important, and I want to finish on this, is about 3 weeks ago we released the nationally approved specification for onboard weighing. In other words, the specification effectively says if you want to buy some onboard weighing equipment for a truck, follow this specification, because it will only tell you what the accuracies are, it will tell you when it's not working and what to do about it, which is very important. And the integration of this into the IAP is now underway. Why is this important? Initially, everyone thought, well, we'll use this as a means of mass compliance. However, we know that if you know the location, the axle group mass and the gross vehicle mass of a vehicle, this allows us to revisit the way we design, manage and use road pavements and, importantly, bridges. I want to talk to you about what we forgot. My very first job was working for the Australian Road Research Board, and I was responsible for the traffic design chapter of the Pavement Design Guide. And what data did I use? I had students counting traffic, and after the first hour, all the other hours looked very similar. They did manage to change the date on the sheets, but I think they were just photocopies. I used onboard weighing, I used on-road weighing systems, but that was here and there. And when we developed our design guide, we applied load safety factors. In other words, because of the lack of information, we applied factors just in case someone was overloaded. And we dreamt that one day in the future, if we had real data, accurate data, how the world would be different. Well, that day is here today. And we have been running for 3 years now an operation in Queensland, in Australia, where we've allowed an A-double, which is 30 metres long, to have 85 tonnes payload, with one difference. We have onboard weighing equipment and we have trust in the mass of the vehicle. What's the importance of that? Simple. Because we now have specific data of the vehicle mass, our bridge engineers have said The load safety factor of 2 that we have applied for the last 60 years can now be adjusted to 1.6 because we have now the confidence in the data that we didn't have, hence why we had a factor of 2. What this means is that we have allowed vehicles onto vulnerable bridges because the vehicle is giving us the mass. So we have bridges in Queensland which have vehicles that travel at a lower mass when there's no mass compliance. But if they have mass compliance and we're comfortable with that mass compliance, they are allowed to travel over that bridge at an increased mass. Not because of compliance issues, but because we are redesigning the way we operate the bridge networks. In other words, safety factors reduce as experience increases. So the load safety factor that we applied on bridges is being diminished as our experience and knowledge of the mass of the vehicle is increasing. And that has allowed us to completely redefine our freight network. To basically say it's the same freight network, but it allows different vehicles if you can come and contribute by giving us openly and transparently with confidence the mass of the vehicle. And that's been a real breakthrough because it's meant that we've been able for the first time to negotiate with bridge engineers who traditionally, as I say to them when I walk into their offices, I see pictures of bridges, but I never see them as pictures after they're open. It's the bridge with no traffic on it, the way they enjoyed it. And so to the bridge engineers out there, knowing the mass of the vehicle allows you to do your job in a different way. And on that issue, I would like to thank you. That's my email contact details, and I hope you enjoy the rest of the event. Thank you.
Thank you, Chris. And as I said from the beginning, this was a joint initiative, Sweden and Australia, when we started. After that, we have got some other countries on board. We have our friends, friends in the Nordic country, Finland, Norway, and Denmark. And now we have also got China on board for this activity. And it's a special pleasure for me to present to you Li Bin. Li Bin, he is the Vice President of the Research Institute of Highway in Ministry of Transport in Beijing in China. He's here together with 2 colleagues, and I will also take the opportunity to say that we are very thankful to Mr. Mats Harborn at Scania in China, who has done really good work to influence on the Ministry of Transport in Beijing and to finally convince them that this is something for China to join and to take the advantages of experiences from other countries and also to contribute to the development in this area. So welcome, Bin Li. The floor is yours.
Good afternoon, ladies and gentlemen. My pleasure to attend this session. It's my first time to attend this session. And my 2 colleagues, Dr. Dong and Dr. Zhang, who maybe you are familiar with them. I'm very glad to have this opportunity to make a brief introduction of the Chinese freight vehicle management status and especially the standard improvement in the freight vehicles. 4 slides for a brief introduction of the management status of the freight vehicle in China. This slide is overall background of road transportation, especially the commercial vehicle operation. As you know, for the past 5 or 10 years, the Chinese economy and the society developed quickly. At the same time, the transportation system, especially the road transportation system, developed more quickly. Especially the infrastructure, just as mentioned as our Minister Li Xiaopeng in the opening ceremony, he has mentioned the infrastructure developed very quickly, especially for the expressway. The total length is becoming longer and longer. It's the biggest network expressway in the world. And also the vehicle numbers is become larger and larger, and more person, more and more family can afford to buy a car. Of course, the for commercial vehicle is also developed quickly, and the road transportation system is take a great contribution in the comprehensive transportation system. Okay. Because of the commercial vehicle related to the public benefits, the security, safety, society, and so on. So in China, the legislation, the regulation and standards for the commercial vehicle is was in charge by the MOT, especially for the standards, just as listed here. The national standards for 1589, standards for the dimension, size, axle load, and mass of vehicle. And also standards for the fuel consumption limits of the commercial vehicles, including the long-distance bus and the freight vehicles. And also, in this year, we have released standards for the safety specification for the commercial bus. And the safety specification for the freight vehicle is underway in processing. It will be released next year. Among the standards listed here, the national standards of 1589, that is mainly the specification, the limits of the dimension, size, axle load, and mass, is the basic and the most important standards for the commercial vehicles. On the other hand, in China, the illegal problem related to the freight vehicles is serious in the past years, a few years ago, the MOT and other ministers together to take action plans of enforcement to countermeasure the illegal phenomena of the freight vehicles. For example, mainly focus on the width limit exceed. For example, the car carrier, the width is too wide, and the height is exceed the limit, and also the overloading. For example, the freight vehicle transport the construction materials, for example, sand, overloading. And the present status is become better and better. For the operating status, monitoring, management of the commercial vehicle. From 2010, the MOT have already set up a nationwide network, monitoring network of the commercial vehicles, especially for the long-distance interurban bus, dangerous goods vehicles, and so on. But in the 2015, the MPS, the Ministry of Public Security, and the State Administration of Work Safety together improved the national the monitoring network to including more commercial vehicles in them. And up to now, almost most of the commercial vehicle was involved in the network by the onboard unit, including the GPS Beidou system and wireless communication, to monitoring the speed, the position, the route, and the other illegal behavior of the driver, and give some warning to the drivers, to the companies. And the new regulation require the vehicle must turn on the onboard unit when they driving. Yeah. Secondly, I will give a brief introduction of the standardization improvement in recent years of the freight vehicles. Just as I have mentioned just now, the national standard 1589 is a very basic national standard for the freight vehicle. Makes the specification of the size, the axle load, and so on. It's very basic. In the newly revised version of the standards released last year, there's a lot of changes, improvements on the limits of size and the interchangeability of the trailer and so on. For the limits of the size of the vehicle, for example, we have increased the width limit of 5 centimeters, and in order to accommodate the two pallet side by side. Yeah. And for the length of the vehicle limit, we have a lot of improvement. For example, for the one vehicle, we have unified the length limits of all the one vehicle into a single standard, that is 12 meters. And for the trailer and the semi-trailer or the center axle trailer, we have also optimized the length of them, especially the center axle trailer is newly added in this version of standards. That will be very helpful for us, for China, to apply the trailer swap application. For the interchangeability of the combined vehicle, we have improvement the specifications for the articulated vehicles interchangeability. And now we are trying to set up a subsystem of standards for the articulated vehicles interchangeability. It will be composed 9 standards together, and now 7 of them was finished and released and applied, and 2 others was underway in the processing. Refer to the ISO standards. The center axle trailer, as I have mentioned just now, is newly added in this version standards. So we have referred to the ISO standards a lot to make our Chinese national standards. And we also try to form a subsystem of the standards for the center axle trailer combinations interchangeability. It will composed of 10 standards, and now 5 of them was finished and released, and the other 5 is also underway. Also refer to the ISO standards. The 2 examples for the limits of the size and the interchangeability standards is only 2 examples of the new version of the standards. And based on the standardization improvement for the past few years of China on the freight vehicles, we are trying to set up a standard system for the freight vehicle overall, including the standard load units, the standard tractor vehicles, and standard trailers, and together. Use the different the load unit, the tractors and the trailers. We can combine different types of the freight vehicles according to different type of task transportation demand. Here is the 3 standard types of the freight vehicles. The ordinary good vehicle, the articulated vehicle, and the center axle trailer combination. Because, as I have mentioned, the center axle trailer combination is newly in China. Before we haven't this kind of freight vehicle. So in the process of the standardization, we have performed a lot of tests for the comprehensive performance for the center axle trailer combination of the one or the car carrier, the two types. And in the next step, the MOT has planned a nationwide demo projects to apply the standardization, especially the center axle trailer combination, in order to develop the trailer swap transportation mode, and in the end, to improve the efficiency of the multimodal transportation system. In the next step, not in this version of standardization, maybe in the near future, we will try to push the newly type of freight vehicle. We believe with the technology development, for example, the intelligent, the advanced safety technology, and with the the demand of the transportation system, we will need more modules, longer freight vehicles to run on the road, expressway of China. So that's all. Very brief introduction of the freight vehicle standardization and management. Thank you very much.
Thank you very much, Ben Li. It was rather interesting to listen to what you are doing in China and that you are really coming up to be a full member of what we are doing here. Nice to hear. Now it's time for John Woodruff to present the first issue of the toolbox, the package for policymakers. John, he is very experienced for 30 years in both the US and Canada, and now you have went back to Canada in order to don't be directly under Trump's supervision. And we are happy to be you here, and the floor is yours.
Thank you.
Yeah.
Thank you very much, Jyrke. Well, the truth is I'm going back to Canada to be closer to my daughter and my sisters and my wife's mother. So lovely to be here. I'm going to talk about the assessing high-capacity vehicles, the package for policymakers, as Jyrke mentioned. It's worthwhile considering, you know, in a model form, what we're dealing with. And we really have a vehicle and infrastructure that we're working and concerned with. And to this point, we've really focused on performance measures that speak to how well the vehicle and infrastructure relate. So is the vehicle geometrically compatible with the road system? Is the vehicle compatible with the strength of pavements and bridges and so forth? So this is what gave rise to performance-based standards, a nice objective way of assessing potential vehicles with respect to the compatibility with the infrastructure. But we've always had this barrier to implementation of larger, more productive vehicles that's really been driven by fear and misunderstanding in society. So we haven't been able to realize the full societal benefit. I think Alan illustrated this very clearly earlier with only 4% of freight carried in this class of vehicle. Mind you, this is a new area and a new area of development. So what we felt in the project was we had to get through this barrier, find a way to be able to communicate with the policymakers. Because at this point, I don't believe the policymakers are well equipped to deal with the counter-arguments against the vehicles, which sometimes are fabricated, sometimes fear-driven, and therefore not very productive in terms of objective analysis. So the metrics for sustainable transport, obviously the current performance-based standards really don't address that very well. Yes, the vehicle is stable, it protects the infrastructure and so forth, but we need to establish comprehensive metrics that deal with the societal costs and benefits, and also measure the efficiency of goods movement, because it's not good enough just to have a high productivity vehicle. You have to be sure it's being used to its potential. Here's a good illustration of the approach of two different countries. Canada allows the Canadian B train to operate on all truck routes, so it's a fully accessible vehicle. Compared that with the US tractor trailer, and this is as big as you can do in the US. So the US, or the Canadian B train, has a 68% productivity advantage over the US counterpart. That's an enormous benefit. So we want to talk and we want to think about how we can better construct arguments to help support policymakers in their very difficult job of convincing the public that this is the thing to do. And I must say that policymakers need to be convinced themselves. So some of the opportunity cost parameters that we might want to consider are things like traffic casualties. We know, for example, that crash frequency is directly proportionate to the distance traveled by any vehicle. So if you can improve your efficiency, reduce the number of kilometers driven, then you will get a commensurate reduction in crashes, which is a safety benefit. We need to think about the broader health benefits or effects, respiratory disease and so forth. Our duty to the planet for decarbonization and reducing emissions. We have to consider mobility, the issues of congestion and lost time, and how can we utilize freight transport efficiency to help improve that. Infrastructure consumption, we often think about bridge and roads as being, the family jewels, let's not damage them, let's not use them. But really, they are the tool of the society. They are what allows us to be productive and efficient and prosperous. And then we also have to think about the larger issues of economic impact on business and commerce and the international competitiveness. I think the Australian example that Chris gave about a mine that was not really feasible because of the low cost of the ore, yet if you could improve your transport efficiency, then that becomes something that's useful. And the last point, of course, is sustainability. Whatever we do, we have to drive that. So an example approach might be to use opportunity cost parameters to assess transport efficiency. And we talked earlier about mass-limited freight. So say you were going to haul building materials. Well, that vehicle is going to be fully loaded before the cubic space has been utilized. Likewise, if we have low-density freight, for example, pillows or insulation, that vehicle will be utilized before the mass limit is realized. And so it drives us to the notion of mass volume freight index, where moving forward, and when we think about our logistics systems, we want to try to utilize the volume and the mass capacity of any given vehicle, which means we start hybridizing freight, making sure that we have reached the GVW of the vehicle, but we also have reached the cubic capacity of the vehicle. And this is a systems approach to transport that the LTL, or less than load freight companies, have been doing for years, but we have to move in the future to try and better utilize vehicles, and therefore that's a real challenge to our logistics community in the future. And then the question is there a sustainable index that might drop out of this? So, because we want to be able to deal with some kind of confidence that we're using the system of transport in the most efficient way. So we know we have vehicle compatibility standards that speak to vehicle stability, trailer dynamics of the powertrain, et cetera. And then the social value metrics within the policy maker toolbox would include things like safety. How would this new vehicle system or this new efficiency improvement translate into lives saved? What are the benefits of the public health level? What are the benefits for congestion, decarbonization, and infrastructure consumption and economic impact? So this is the metrics. This bottom set is the metrics that we want to include in the toolbox for policymakers. And I stand before you with an incomplete study on this. This is part of the reason that we're doing this in the project. And it is a lovely project because it's international in nature. Policy matters are not just an independent sort of element. They are different in every jurisdiction. So we want to be sure that we can have all the input from various countries and the various priorities that they have. So the toolbox needs to be generic to the extent possible, and each country can fit its own rules to that. So that really drives us to defining the particular metrics we wish to choose, and then we leave it to each independent country or territory to assert the criteria that they feel is appropriate for their conditions. Again, sustainability. Can we develop a sustainable index, and can a universally applied sustainable index be achieved. You know, we need to think about modal compatibility because we want to think in terms of a transport system, not just the vehicle. We want to think about the ship. We want to think about rail. We want to think about alternative forms of transport. Electrification, hybridization, those sorts of things. In fact, as we create this toolbox, we can't think about today. We have to be thinking about tomorrow and very far in the future in order to ensure that we don't inject unintended consequences and having artificial elements that may produce negative returns. So we have to be very thoughtful about and careful about how we do this. We also want to encourage load migration, say from smaller trucks to larger trucks, so that we get fewer truck miles at play. And also we have safety and societal service issues. And as I said before, the vehicle load factor, I think in the future, this is a big one. Once we optimize our vehicle system, then we must find ways to be able to utilize those vehicles. So this is a chart that I put together assuming a 10% reduction in truck travel distance in the US. And I approached it this way because quite often, traditionally, you look at policy in general, and you'll say, okay, if I do X, Y, and Z, how does that affect efficiency? In this model, we're simply saying, let's assume we do something constructive. And you know, it could be a multimodal dispersation. It could be improving your size and weight policy. But if you could reduce the truck travel distance through improved transport efficiency, then we would save something in the order of 330 lives per year. You can see that close to 20-some thousand crashes could be avoided. You would have a significant reduction of fuel and significant CO2 reduction. And it rolls up to $16 billion annually. So that's $16 billion every year, just for 10%. And that goes year after year after year. So that's a compounding benefit that is a lost, that's an opportunity cost facing us at the moment. And then this last slide, I want to put this up just to illustrate how powerful freight efficiency is in terms of a safety strategy. So I have here a table that's containing 2 crash avoidance technologies that have been mandated in Europe, certainly. One is electronic stability control. If that were put on every truck in the US, we would save about 126 lives per year. If we put forward collision avoidance and crash mitigation, so autonomous braking devices on all trucks, we would save perhaps 99 a year. So, but if we simply improve our efficiency by 10%, we're looking at 330 lives. So really, transport efficiency is a surrogate for safety, and it is more powerful than some of the modern technologies that we're looking at today. So with this, I'll leave you, given our time restrictions, but thank you very much for your attention. Thank you.
Take a seat up here. Thank you very much, John. And now we have come to next phase of this session, because you know we have heard 4 speakers, and you are going to take your seat up here. And then we have 4 other experts who have been sitting here listening to you, and you are also invited to come up. I will present you as soon as you have arrived. 1, 2, 3, 4, and finally number 8. Welcome. The new faces are from the left, Vesa Männistö. He is representing the Finnish Transport Administration. He is a member of the working group. We have Bernard, Jacob from IFSTAR in France. We have Stefan Larsson, who is representing ASEA. And then we have finally David Seaborn from Cambridge University. We have heard now from Alan McKinnon that these new solutions, high-capacity transport, will have a significant positive impact on decarbonization. We have heard from Chris that you are building trust and building your activity on trust. We have heard from China that you have a tremendous program and activity now in order to achieve standardization, and by that also a new way of using trucks for transportation in China, and also to be more directly involved in the global society in this area. And finally, we heard from John about the toolbox. And I didn't say that in the end, in June next year, the working group will come out with a report, not only a nice report, but useful report. And the most important thing will be this toolbox at the end. So now I will invite the jury, Vesa, Bernard, and Stefan, and David. What's your comment when you have been listening to your colleagues? Are the trucks on the right track? And what about trust? We have a situation where the rail sector, the man in the street, is fearing for long and heavy trucks. We have heard from Chris that we have now trust from the industry, we have trust from the authorities, but what about the man in the street and the railway sector? How can we keep on in this direction in order to get everyone on board? Vesa, could you start, please?
Good afternoon. Yes, you are on the right track. As a history, Finland has been, I think, more liberal than many countries in high-capacity transport. We started with 60 tons in 1990 and with 76 tons in 2013. And now we are piloting up to 104 tons and 34 meters. And it is very nice to hear from the research all over the world and the opinions of the experts that the experience what we have got from our pilots, they are in line what the research part of the world is finding out. Of course, there is a problem with, for example, modal shift. But like our industry in Finland says that they understand that there is a role for railways, there is a role for high-capacity transport. But because the industry is developing so rapidly, rail transport is not a short-term solution anyway. You can't build a railway if you need transport in 1 year. So you have to have a mix of those both. So I really see that we have to go forward in a very brave way as we have done so far.
Thank you, Vesa. Bernard, you are a bridge expert together with Chris, and now you have listened to his new ideas and based on experience from Australia. Is this something that we can go for on the global scene to reduce this load safety index?
Thank you. I will speak in French because there is translation. Donc, je vais parler au nom de l'infrastructure.
So the lorries, first of all, are frightening when we look at them, but we can explain this very well. Actually, there are simple rules, as has been mentioned by the speakers. When the size of the trucks is increased, when the volume and the weight are increased, then the length will be proportionally increased too. And the axis load, however, must not be increased at the same time. As we saw in Canada and the US, that means the number of axes is increased and the axis load remains the same in order to protect the roads. In Sweden and in Finland, we have trucks that have 60 to 90 tons with additional axes, however, so that the load is not higher. This is very important. The axe load has to be maintained, but the length of the trucks have to be at least proportional in order to lengthen, to increase the weight. When you increase the weight, the length has to be increased so that the weight is distributed over a longer length. And secondly, what is also very important for the bridges, when the weight is to be increased considerably, bridges have to be strengthened. In the US, a formula has been introduced and also in Australia, a bridge formula. I'm not going to explain its details, but that means the total weight of the truck will be limited by 2 parameters. That's the number of axes and the total length, or the difference between the distance between the axes. So what you can do is you can increase the weight of the trucks, provided that the truck becomes longer and that you have a sufficient number of axes and that the weight is distributed equally in order to avoid damages for bridges and risks. And the bridges and the roads are built for a longer lifetime than the vehicles. The vehicles can live 20 years and the bridges about 100 years. So these developments have to be taken into account. When you load the trucks, you have to bear in mind that there are infrastructures that are not always strong enough. So these are the criteria that are important. If you take into consideration these facts, the weight can be increased without damaging the infrastructure.
But I am convinced by you. Sorry. David, you are not a bridge expert, but you are in this field. What's your comment?
Thank you, Joko. I was blown away by what Chris had to say about what the Australians are doing. I think that, first of all, the obvious business about the number of boxes and having some sensible standards is something that we really need to take on board here in Europe. It's madness not having a bit of control over this. That's probably the easy thing. What blew me away was the power of that trust in data to implement and introduce innovation in the industry and to get over the barriers associated with convincing people and allowing the general public to trust in these larger vehicles. And I think that's really the critical thing. I was always also very impressed with John's statistics about the power of higher productivity vehicles to improve safety. It's not an obvious connection until you look at it from a safety person's perspective. But when you see that, the huge effort that goes into all of these technological fixes for vehicles compared to just having fewer of them, it's an obvious thing and it's something that we really need to use in our persuasion of policymakers and the public. And the final thing was that I didn't quite understand the statistics in China, but there's something, either 9.5 million or 13.5 million trucks. We have 400,000 trucks in the UK. I spend most of my working life trying to decarbonise those 400,000 trucks. I can see that that's not going to be very important compared to the 13.5 million in China. And so clearly we need to do all we can to help those in the very rapidly developing countries that to help them with their decarbonisation problem, because that's way more important than ours.
Thank you, David. Stefan, you are representing the automotive industry, and it was also put in the title for this final panel discussion, high productivity vehicles of the future, market, technologies and regulations. But your comment after listening to the speakers and due to the fact that you have this overall view on what is going on from the industrial side.
First of all, of course, I like to confirm that I think that we are moving in the right direction. The problem that we have seen, though, that it takes an awful long time. When I was involved in first time in this activity, it was in 1982, where I introduced a principle of transport class system that I actually took as an inspire from the United States. Because I happened to work at Freightliner Corporation, because they were the distributors of Volvo truck at that time in the United States. And I found out then in Oregon, they were driving with triple combinations on the road. And when I came back to Sweden, I thought, why do we have to have the same number of the size and lengths if the infrastructure, certain part of the infrastructure can actually take more? It's more a matter of having something that is flexible, that you can actually take advantage of longer and heavy vehicle on the infrastructure that can take it, and then have a possibility to split this into other combination when you cannot use that when you don't have the infrastructure. So from that point of view, I think what is very crucial, and that was highlighted by the representative from Australia, is that you have to be sure that you are on the right infrastructure with the right vehicle combinations. That is crucial. The problem that we ran into is a little bit similar, because I was working for Volvo in Sweden at that time. And when we were joining the European Union, the forest industry was quite concerned, because they were supposed to align themselves to the vehicle dimensions that was relevant at that time. And we run into the same issue with respect to the mining issue, but in Sweden it was the forest industry. Although this was not accepted by the rest of the transport operators, because in Sweden at that time, all transport was more or less performed by 24-meter-long combinations. So we had to come up with something that actually gave us a result that we could go forward. And then we changed the name of the transport class system into the European Modular System, EMS. And the way that we solved the issue, as you might be aware of, is that we allowed one EU modules for transport companies coming into Sweden, and later also to Finland. And that was a condition that we could maintain our 24-meter-long combinations. So this was the way that we dealt with that issue. What I have learned, though, is that the politicians are not very much impressed by the fact that we reduce transport costs. It's actually worked to our disadvantage because of the reaction from other modes. So therefore, I believe that one very, very important element is the sustainability index. Because what we have seen is the lack of political courage, I would say. And I realized that also because I joined ASEA, and I work with the size and weight issue, but I learned that we cannot sell it based upon improved or reduction of cost, because it works not necessarily to our advantage. So I have been, for the last 10 years, I have been working with the CO2 issue and heavy-duty vehicles, because then we saw, of course, the benefit for the operators by having the possibility to make more efficient transport, but the society did not see the same positive effect. But with CO2 reductions, we have this, and then when Mr. Woodrow's sustainability issue, I think this is what we need to have on top of it, because it's not only CO2, it's also a lot of other elements that needs to be incorporated. And hopefully then, I have been on this issue now for 35 years. If the pace is not increasing, we will still be discussing this issue 2050, when we are supposed to reduce the CO2 in Europe by 60%. And we know all that has been involved in this shows that the modal shift strategy doesn't work. So we have to address the reduction of road transport, which is responsible for 75% of land transports in Europe, and we have to introduce longer and heavy vehicle. That is the most cost-effective way of reducing CO2 from road freight transport.
Thank you, Stefan. I have a question to you, Mr. Libin. We heard the comment from David that you in China is representing a really big amount of trucks. And we also know now that China is taking the lead, in fact, in the climate issue. We have some problem with United States for the moment. I saw on my phone today that it has today been taken the decision that the United States will not anymore support the Paris Declaration. So a question to you, what about trucks in China and CO2? You didn't mention directly in your presentation what you are doing in this field, but it would be very interesting to hear about what you are doing on that.
Thank you very much for the attention for Chinese trucks and climate changing. China is a developing country, but is a very developed very quickly country. So for the truck, for the freight transportation in this area, we have think about different solutions to improve the situation, the level, the technical level, management level of the freight vehicle, the ordinary, the newly. In the ordinary solutions to improve the truck technical or management, there's a lot of experience we should learn from the Europe. For example, the modular EMS and so on. So in the new world of the standardization, just as I have mentioned just now, we have learned a lot of from the ISO standards from Europe. This improvement is the basic solution to improve the whole situation, including safety, the decarbonization. But on the other hand, for the internet technology, intelligent technology, in this area, the China has its own advantage. For example, the newly the technology, the market advantage. For example, the monitoring system, we have successfully set up a nationwide monitoring system using the regulations to require all the trucks to introduce the onboard unit to monitoring the situation, the operations data. And on the next step, we have planned to apply the intelligent, the advanced assistant safety system, for example, the AEB, the LKA link keeping technology, link departure warning technology into the bus, into the trucks in the next step. So we, as developing countries, we solved the truck problem, we used different solutions at the same time for safety, for decarbonization, for the efficiency improvement. So, thank you.
Thank you. Thank you. My friends, the time is running, and but if any of you would like to make a final comment, it's an option for that. Yes, Stefan?
I think, I mean, it's important to note the European legislation regarding CO2 from heavy-duty vehicles was decided earlier this month. One important element in that legislation is now that EMS combinations are part of the combinations that will be modeled regarding efficiency. So this is a step in the right direction.
Okay, good. Bernard, please, in English, if you can.
Oui, je voudrais juste faire une remarque, étant assis à côté du président de la Société internationale du pesage en marche, pour dire que l'accroissement des charges doit s'accompagner aussi d'un contrôle plus strict des surcharges, parce qu'on peut augmenter les charges de manière maîtrisée.
Es muss auch mit einer Kontrolle der Überlast einhergehen, denn wir
This has to be combined with the control of overload. There's a problem of overload in Europe that can harm the roads. That was also integrated in the European directive with regard to the weight in its renewed version of 2015. Here it was said that the member states have to improve their control and that the states have to report on the improvement. All what is combined with the increase of loads has to be associated with stricter controls of the countries. This is an element we must not forget.
So, thank you everybody for joining us, and thank you the audience. And next event will be the Mexican reception, the big tequila party, and somewhere we will meet there. Thank you very much. In the zoo.